Hey class, this lesson is on quadratics. And of course, in many sports, we have like objects that are thrown, kicked, or hit, and then proceed with no additional force of their own are called projectiles. And these pass the projectiles model quadratic functions. We have previously talked about quadratics in transformation section. The graph of a quadratic is a parabola, and there are two specific things in that parabola that we will look for. We will look for the vertex of the parabola. This is the turning point that can be either a max or a min, and we're going to look for the axis of symmetry, which is a vertical line that divides the figure in half. And the two halves match exactly if folded along that line. So if we think about it, if I think of my parabola here, so in this case, my vertex would be a max, and in this case, my vertex would be a min. All right, how do we find the vertex? Well, there's two forms of quadratics. We have what's called the vertex or standard form, and it looks like this, where the function f of x equals a parentheses x minus h squared plus k, where in this form h and k are the vertex. And then the other form is the generic form, and this form looks like ax squared plus bx plus c, and we'll use this little formula here to find the first part of our vertex. So looking at vertex form, find the vertex of each quadratic. Well, since it's in vertex form, we can easily find the vertex by looking at h and k. When we name the vertex, the h, we're always going to take the opposite of the sign. So that would tell me the vertex is not positive 5, but it is negative 5. And my k part is going to be negative 6. So that's the vertex of this parabola or quadratic. Here for b, the vertex, we're going to do the opposite of negative 1, which would be positive 1, and the k is going to be positive 3. And that's all you have to do if you're finding the vertex in vertex form. So generic form, if you notice, does not look like the vertex form because it's not. So what we're going to do in this form is we're going to use this little formula where we're going to take the opposite of b divided by 2 times a. So here, if you notice, remember, this is a, the coefficient in front of your x squared, and then your b is the coefficient in front of your x term. So to find h, we're going to substitute in the opposite of b. So b is 2, so I'm going to plug in a 2 there. And then our 2 times a, which is 1, and we simplify. That's going to give us a negative 2 over 2, which gives us a negative 1 for our h. Then to find k, we just substitute our h back into the quadratic. So we're going to evaluate it at 1. So we're just going to substitute 1 everywhere that we have an x. And then we're going to simplify that side, which will give us a negative 4. So the vertex will be negative 1, negative 4. For the second one, we're going to do the same thing to find h. So this is a, this is b. So we're going to do the opposite of b divided by 2 times negative 2. This is going to simplify to negative 2 over negative 4, which gives us a 1/2. We're going to substitute 1/2 into the function. So we've got a negative 2 times 1/2 squared plus 2 times 1/2 plus 12. When we simplify all of that, we end up with 25 over 2. So the vertex will be 1/2 25 over 2. Of course, if you need to, you could change this to decimal and do 0.5 and then 12.5 instead of fraction form. So what we're going to do now is we're going to use the vertex and intercept to graph. And it says, give the equation of the axis of symmetry. So let me go back here real quick and talk about the axis of symmetry. If I had to name the axis of symmetry for these two quadratics, all I'm going to do, it's a vertical line through your x or h. So in this case, my axis of symmetry would be x equals -5. For b here, it would be x equals 1. Here, it would be x equals -1. And then for this example, x equals either 1/2 or 0.5. So to find the vertex, this is in vertex form. So our vertex will be the opposite of this h. So it's +3, and then your k is -1. Our axis of symmetry would be the line x equals 3. Now to find intercepts, we are going to substitute 0 for our y value because we want, well, it says intercept, so we can find, I tell you what, let's find the y-intercept. So to find the y-intercept, substitute 0 for x. So remember, f of x is your y. So that would mean f of x equals 0 minus 3 squared minus 1. When we simplify this, we will get a -3 squared minus 1, which is going to be 9 minus 1, which is 8. So our y-intercept is 0, 8. If you had to find the x-intercept, what we would have to do is substitute, set f of x to 0 and solve it. But really, all I'm going to do is just use this y-intercept to help graph my quadratic. So I'm going to come over here and plot -3, excuse me, +3, -1. So I'm going to go to the right 3 and down 1. That's my vertex here. And then my axis of symmetry is going to be this line x equals 3. So I'm going to plot 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. So go back to transformations and think about the shape. I know my graph is going to be turned up because my leading term here is positive. So I can draw my axis of symmetry, this vertical line through this vertex, and I know from this point that equidistant from this point on the right hand side, I'm going to have another point, and then I can sketch my quadratic using those 3 points. Here we're going to do the same thing, graph using the vertex and the intercept, and then give the equation of the axis of symmetry. I forgot to do the domain and range, so let's go back for this one. Your domain is -infinity, +infinity, and the range, so the lowest it's going to go is -1, and it turns up. So my range is going to go from bracket -1 to +infinity. So the first thing I'm going to do is let's put this one in order, in descending order. And we're going to use the -b/2a to find the vertex here. So we're going to do the opposite of b divided by 2 times a. and that's going to simplify to give us a positive 1. And we're going to substitute 1 into the function to get the k. So when we simplify that, we get 4. So our vertex is positive 1, 4. Now let's find the y-intercept again here to give us another point we can work with. So to find the y-intercept, all you're going to do is substitute 0. Now it doesn't matter which form you use because it's the same equation. I'm just going to go to the beginning and do 2 times 0 minus 0 squared plus 3 and get 3 as our y-intercept. Our axis of symmetry is going to be x equals the x value here, and that's going to be x equals 1. So we can graph here over 1, up 4 is the vertex. So this is the vertex. Now I'm looking at this, think about that negative there and the transformations. Remember, the negative is going to reflect it down. So I know my graph is going to turn down. I'm going to plot my y-intercept here. So I know this is my axis of symmetry. So I know on the right-hand side, I'm going to have the graph matching up. So there is the graph of our quadratic. This last example is an application. It says a ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x in feet, can be modeled by our quadratic equation here, where x is the ball's horizontal distance. So we're talking about, when I look at the graph here, and I'm thinking about graphing, this x value is going to be how far it's traveling out. And then our y value is how high it goes. So our y value is the height it will get. So what is the maximum? That's the key word. Maximum height of the ball. And how far from where it was thrown does this occur? So when I see maximum or a minimum, I'm looking for the vertex. So what we're going to do is find the vertex first. So we're going to use, because this is in general form, we're going to use negative b over 2a. So we're going to substitute. We've got a negative 3.2 divided by 2 times a negative 0.8. You've got a calculator. You can plug this into the calculator. So that gives us a distance of 2, or that gives us an h of 2. So that is the horizontal distance. So to find the vertical distance, which is the height, we are going to substitute 2 into the function. So when I substitute negative 0.8 times, or 2 squared, and then plus 3.2 times 2 plus 6, and I simplify that all out, I get 9.2, which is the height of the ball. So A, the height, well, I'll get it right here in a second. A, the height is 9.2 feet. And how far from where it was thrown, how far is 2 feet. B wants us to find how far the ball travels horizontally, all right, which is this is our x value before it hits the ground. Well, think about the ground. The height of the ground is 0. What models the ground here, the height of the ground, is f of x. So what we're going to do is we're going to sub 0 for f of x. 3.2x plus 6. And we're going to solve the equation, in this case, using the quadratic formula. So we're going back to using the quadratic formula, which was negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is negative 0.8, b is 3.2, c is 6. We're going to substitute these values in. So I've got negative 3.2 plus or minus the square root of 3.2 squared minus 4 times a. I'm just going to put negative 0.8, which is the same thing as negative 0.8. Negative 4 times negative 0.8 times c, which is 6, all over 2 times negative 0.8. So we're going to use the calculator to simplify all of this. So what I'm going to do is plug everything. I'm going to do negative 3.2 plus the square root of all of this, and then divide it by 2 times negative 0.8. And then I'll do the minus of it. So you get negative 1.39 and 5.4. Well, the height can't be negative, so our horizontal distance, or how far it travels, is 5.4 feet horizontally. All right, the last thing is graph the information. So what we're going to do to graph is come over here. So when we look at this and the graph, our height, it says the ball is thrown upward from 6 feet. So that means when I start here at 0, I'm going to go up 1, 2, 3, 4, 5, 6, and then throw the ball out from here. So it's going to go out something like that. So what we're going to do is use our point that we found here, our vertex, which, remember, it, whoops, undo, there we go. We're going to use our vertex, which is 2, 9.2. So I'm going to come over here and plot, go over 2 and go up 9. So this is 6, 7, 8, 9. I'm going to estimate it right there. We can also use what we found in C, which is where it hits the ground. So this is an x-intercept. So 5.40 is another point we can use. 1, 2, 3, 4, 5.4. And then we can just kind of sketch our quadratic using those 3 points. Well, I hope the lesson has helped. Let me know if you have questions in this particular section.